Hello students, I am Professor S.N. Shukla. My total teaching experience in this field is around 40 years. I worked as an assistant professor in Prora Rural Engineering College, Loni, for the span of around 27 years. During this period, I worked as a head of the department of first year engineering. I was dean academic in PREC Loni. For few days, I worked as an in-charge principal. And during this span, I was also a member of Board of Studies in engineering faculty of Savitribai Phule Pune University. In 2011, I shifted from Loni to Nasik. There, I worked as a head of the department in Matoshri College of Engineering and Research Center, Nasik, for the span of around 11 years. I got it retired from Matoshri College of Engineering in 2021, and then onwards, presently I am working as a head of the department of first year engineering in Pune Vidyarthi Graha College of Engineering and S.S. Dhamankar Institute of Management, Nasik. During my whole schedule, I was a paper setter, I was examiner, moderator, and I was the member of local inquiry committee. Also, I was the member of UGC selection committee of Pune University. This is a very brief introduction. During this period, I written 3 to 4 books of engineering physics based on the syllabus prescribed in the Pune University. My first publication was Vrinda publication, published by Vrinda Publication, Jalgaon. Then I published engineering physics in Technoma publication, and now presently my book is published by Technical Publication, Pune. I try to make subject as possible as more simple while writing the book. And as I know that unnecessarily students take tension about a very, very interesting subject about which I belongs, that is what? Physics. You know, guys, the physics is the base of almost each and every field. You enter in every field, you will see there is the base of physics directly or indirectly considered. Even our day-to-day life, we come across with the principle of physics. The very simple example, that is what? You will see. Everyone knows that when you are working in home, for example, you are preparing a tea. While preparing tea, you will take help of your gas stove and you will let on the gas. While जेव्हा आपण गॅस स्टोव पेटवतो, कशाने पेटवतो? लायटरनं पेटवतो. मग लायटरनं पेटवतो, मग आपण लायटर घेतो, बर्नर जवळ ठेवतो आणि we'll press it and we'll see that ignition is there. What is the principle behind it? The physics. That is what you will see, that lighter has a small crystal, that is what? Quartz crystal, and based on the principle that is piezoelectric effect. Number of examples are there. Oil drop floating on water surface come across with the sun radiations, sunlight. You will see that oil drop exhibit different color. Develop the soap bubble, throw in a air, you will see when light come across to it, you will see that it appears in a colorful way. Number of examples are there, number of applications are there, number of basic principles are there, and that is what all involved in the physics. As much as you take interest while understanding the subject, you will see that it becomes easier and easier. Unnecessary, you are taking tension about this. Anyway, now here I am standing in front of you to discuss about few topics. First, 2 units which are mainly required to prepare for your upcoming end semester examination. You know that the examination structure defined by the Savitribai Phule Pune University, it is divided in 2 parts. One is nothing but end semester examination for 30 mark, and second is nothing but end semester examination for remaining 70 mark. There is no mandatory passing as far as in semester examination concerned, but will help you, the scoring in semester examination definitely will help you to score in a subject up to your expectation, as per your expectation. End semester examination, out of 70, it is mandatory to secure 28 mark. In semester, whatever, even you get the 0 mark, and end semester, if you have 40 mark, subject may be considered as a pass subject. But suppose in semester out of 30 you are having 25 mark, and end semester it is less than 28 mark, suppose 25 plus 25, the total marks comes out to be 50, but even then the subject may consider as a fail. That all these things you know betterly. My interest is nothing but you try to score as possible, as maximum mark as far as end semester examination concerned. For end semester examination, which is already I told you, that is for 30 mark. Marks based on first 2 unit. I am talking about the physics subject. The first units are, the first unit is nothing but unit 1, that is optical phenomena. In this you can see the first chapter, that is interference of light. Interference of light. Second is nothing but diffraction of light. Diffraction of light. And third is polarization. Polarization phenomena. Let us have, in brief, try to understand all these optical phenomena. You know, light travels, as far as very first, based on the Newton's corpuscular theory, propagation of light in terms of a corpuscles, particles. But then the Huygens wave theory comes forward. Huygens electromagnetic theory comes forward, and there it is understood that light has wave nature. It consists the vibration of electric and magnetic field vector. Their vibrations are mutually perpendicular with respect to each other. Electric field vectors vibrates perpendicular to the direction of propagation, and magnetic field vectors, which are perpendicular to the vibration of electric field vectors, they are also perpendicular to the direction of propagation of light. Mainly, light propagates due to the vibration of electric field vectors, which are perpendicular to the direction of propagation. It proves that light waves has transverse vibrations. Transverse vibrations means the vibrations which are perpendicular to the direction of propagation. Okay. It proves the wave nature of light. Now here, when you talk about the first, interference of light, let us have some brief discussion about this phenomena. It's very important. As just now I given the example, the oil drop when come across with the sun rays, sunlight, or the soap bubble come across with the sunlight. You might have seen the feather of peacock exhibit the different color. The neck of pigeon exhibit the different color. So the oil drop exhibiting in terms of the colorful pattern, that is based on the phenomena that is what? Interference of light. What do you mean by it? Interference is nothing but the simple, a very simple way. It proves that energy conservation principle does not get violated. You must be knowing energy conservation principle, that is nothing but neither energy can be destroyed nor can be generated. Only distribution of energy observed from one point to another, maximum to minimum. Same thing when two or more than two waves, like this you can see here. That is, suppose there are two sources, S1 and S2. Here is the screen. Source is S1, second source is S2, and two waves, they are traveling in the same direction. One wave started from the first source S1, the second wave started from second source S2. If you observe this, that two waves, they are generated from two different sources. They propagated having certain amplitude, one wave having amplitude A1, second wave amplitude A2. They are meeting on screen somewhere at point P, suppose. When they meet at point P, if you observe that crest of one wave is falling with the crest of another, trough of one wave is falling with the trough of another. How it could happen? Because they have the path difference in integral multiple of a lambda, where lambda is nothing but the distance traveled by ray, distance traveled by a single wave, that is from 0 phase to the 2 pi phase. So when path difference between two waves is integral multiple of a lambda, it shows that Amplitude of one wave is meeting with the amplitude of another wave. Amplitude of both the waves, they are combined and the total amplitude becomes maximum. That is what A suppose. Addition of two amplitude. And when amplitude is increased, you know intensity is directly proportional to square of amplitude. So intensity is automatically got it increased and this point appears as a bright point. In second situation, suppose two waves are not having amplitude in an integral way. That is, suppose the wave started from this just a minute. One source, second source is S1, S2, here is one wave and here is another wave. See the difference between two waves. Here two waves starting from two different sources, approaching in the same direction, having amplitude A1, A1, A2. The difference is nothing but crest of one wave is not falling with the crest of another, it is falling with the meeting with the trough of another. Trough is meeting with the crest of another. It shows that every wave will try to cancel the effect of another one. And it shows the final amplitude, instead of getting added, it becomes subtracted. That is, amplitude becomes 0. A1 minus A2 becomes 0. Amplitude is 0, intensity is 0. It shows that obviously the point is dark. In short, interference is nothing but redistribution of energy from maximum to minimum. When point is bright, constructive interference. Point is dark, destructive interference. Intensity in constructive interference is maximum. Intensity in destructive interference is nothing but minimum. It gives us an idea about that is nothing but that main interference phenomena based on the basic principle, that is nothing but principle of superposition, in which that resultant amplitude is nothing but an algebraic sum of vector addition of all the amplitude of the individual wave trends. So this is what the basic understanding about the interference. The condition for, as already I told you, the path difference is nothing but integral multiple of lambda, constructive interference or point is bright, and when path difference is nothing but an odd number multiple of lambda by 2, this is what? Destructive interference or dark point. So path difference means what? Here the difference between the path traveled independently by each of them. The distance traveled by ray started from S1. Distance traveled by ray started from S2. How much is the distance independently they travel? What is the comparison? What is the difference? And that path difference is nothing but integral multiple of lambda will give us the constructive or maximum intensity. Odd integral multiple of half the lambda will give us the minimum intensity or destructive pattern. Anyway, we'll not go in detail in that direction. The main topic, what we are going to understand from examination point of view, that is, after understanding the basic concept of interference, the main topic is nothing but the first topic, interference due to thin film. Interference due to thin film. Interference due to thin film. Thin film. That is, when two glass plates separated by a different material, for example, liquid material is there, solid material is there, or if no material, automatically air material is there, air medium is there, so we can say that it acts as a thin film with a very small separation, almost 10 raised to minus 3 millimeter. So if we consider a film having a constant thickness, we can say having uniform thickness of the film is uniform, it is exposed to light rays strike on all possible points of the upper surface. From upper surface we'll get it reflected, partly refracted inside the film medium having certain refractive index mu. If it is air thin film, so refractive index is nothing but equal to 1. The refracted ray will come to the lower surface of the film. So and again it is reflected inside and will emerge outside of the film. From here also you will see it is inside reflection and will come as a transmitted. You can see that single incident ray is divided into set of reflected ray and set of transmitted ray. These reflected ray traveling in the same direction. These transmitted ray, they are also traveling in the same direction. So there is strong possibility of getting superposition of these waves, that is interference of these waves. These waves will interfere and we'll see the interference will occur. Then in what is the nature of interference? In what way the superposition occur? Either in a maximum site, bright, or in a minimum site, dark. When they are meeting in a maximum site, that is crest of one is already discussed, falling with the crest of another, so it has to be appear as a bright. If it is not there, crest is meeting with the trough, so cancellation effect converting into a dark. So to find out the nature of interference, we have to have the path difference between rays. So we'll have to calculate the path difference. And once we get the actual path difference by considering all situational constraint, we can then equate it to the standard condition equal to n lambda for deciding the bright and equal to 2n minus 1 lambda by 2 for dark. Okay. This we discuss when we try to understand by taking one particular question. So in this, main is nothing but thin film having uniform film thickness. It may even also possible, that is, the film is not uniform. It is not having constant thickness. Its thickness is changing. It has a variable thickness. It means two planes, two glass plate, they are separated with certain angle. They are separated at very small angle, that is theta, and this is what nothing but contact point of these two surfaces, these two glass plate. Let us say O is the contact point, O is one plate, OB is another plate. So thickness of the film, because in this medium may be liquid, may be solid, or maybe if no particular medium is there, air medium is automatically present. So at the point of contact, thickness of film is 0, and the thickness goes on increasing as we go away from point of contact. This type of film is known as non-uniform thin film. Non-uniform in terms of having a variable thickness, changing thickness, it goes increasing as we go away from point of contact. This film is known as wedge shaped thin film. Very important from examination point of view. Wedge shaped thin film. Wedge shaped thin film. Okay. So here also we try to see that path difference between two rays, when film is bright, when film is dark, like this. So in interference, main two topics, one is nothing but interference due to thin film having uniform thickness, and interference due to thin film having non-uniform film thickness. That is uniform film thin film and wedge shaped thin film. Okay. Second topic, application of this. Mainly wedge shaped thin film is used in case of finding or checking the optical flatness of any surface. The application of interference by using wedge shaped thin film is nothing but to obtain or to analyze, to study the optical flatness of the surface. And second application is another way important, that is what? That is in anti-reflection coating. In particular, you can see the glass is coated with some material, and you can see that reflection is decreases and transmission is enhanced, that is increased. That is mainly used in the camera lens or in the solar panels. Interference phenomena is also used in interferometer to obtain or to calculate the thickness of any particular object or length of any particular object with the high degree of accuracy. So in first chapter, interference phenomena, we have seen that is interference due to thin film is important, and uniform thin film and non-uniform, that is wedge shaped thin film. The second chapter is nothing but diffraction of light. Second chapter, diffraction of light. This is also there. Also we try to understand the phenomena of interference only. So this is what? Diffraction of light. Okay. Diffraction of light. Here you can see, suppose single slit having a small width, let us say A, exposed to light. This is what the open region of the slit, and the set of light rays are allowed to pass. When they pass through the slit, suppose AB is a slit. When they pass through the slit, as per the Huygens principle of secondary wavefronts are developed. As per the Huygens principle of secondary wavefront, each and every point on the surface of secondary wavefront acts as a radiator or acts as a secondary source. And from every secondary source, the new rays generated and they travel towards the direction of screen. So here n number of rays are generated, they travel towards the direction of screen like this. Like this. So here you can see the light rays, when they come across with any obstacle in their path, they change the direction. Normally light travels in a straight line, but as soon as this is what nothing but an obstacle, light is coming like this. When it come across with the tip of the obstacle, what happened? It deviated. Deviated means it changed the direction. So that is nothing but bending of light. And the understanding of phenomena of diffraction is nothing but the bending of light taken place around the edge of an obstacle. And this deviated light, when they are traveling in the same direction, obviously they will get it interfere, and once they interfere, so the nature of interference occurs and the pattern of interference is produced like this. Somewhere that pattern has maximum amplitude, somewhere it has variable amplitude. The amplitude where it shows the maximums, let us say P point, this is nothing but the center point, it shows the maximum amplitude. It is due to the fact that all the rays, they travel almost equal optical path. Equal optical path, it means that there is no path difference present in between them. No path difference, so obviously all the rays, they are traveling with the zero path difference, and the crest of every wave is getting interfere or superimposed with the crest of another, and naturally which results into giving us the maximum amplitude. So maximum amplitude, obviously the maximum intensity, as intensity is directly proportional to the square of amplitude. Okay, but after this is what position known as a central maxima, CM. Central maxima may even consider as a principal maxima or prominent maxima. On either side of the central maxima, you can see this is what nothing but the slit I have shown here. This is the slit here. So here the central maxima, here is the central maxima, ray coming like this, and from this point here the ray are meeting to this direction also, to this direction also. Okay, so here you can see that ray traveling in the same direction with equal optical path difference gives us the position of central maxima. But when they are meeting with certain angle, when they travel with certain angle, because diffraction is nothing but the bending of light. So when they meet with certain theta, meet with certain angle, so obviously the intensity has to get it affected and will show the reduction in intensity. So immediately after the central maxima, there is the position of first secondary minima. Then first secondary maxima having certain intensity, definitely lesser than the intensity of central maxima. So n number of secondary minimas, P1, P1 dash, P1 double dash like this. Then P2, the central maxima, first central maxima, P2 dash, n number of secondary minimas, n number of secondary maximas on either side of central maxima. This is nothing but the phenomena of diffraction. Now as we have considered only one obstacle, only one slit it shows that is the diffraction due to single slit. This is nothing but diffraction due to single slit. And obviously, after having the detailed calculation as far as considering their path difference, we can easily try to obtain the condition for what is the required condition to obtain the central maxima, condition for central maxima, condition for n number of secondary minimas, condition for n number of secondary maximas in single slit diffraction pattern. This is nothing but the intensity distribution pattern produced by the rays when they got it diffracted from the surface of single slit. Now, instead of single slit, suppose if we consider n number of slit, more than one, if we consider n number of slit, that is slit S1, S2, S3, S4, S5, etc. This arrangement is known as a grating. So grating consists arrangement of large number of slits. Practically, optical grating is prepared like this on glass plate by taking fine diamond point. Large number of lines are marked. The spacing between two lines acts as an open region. This is what the open region. Open width which allow the ray to travel, and the line width acts as a opaque region. So this is what A, the open width. This is what B, nothing but the opaque width. Opaque width means does not allow light rays to pass. So when light rays are, the parallel beam of light ray allowed to pass through this grating, those rays.
मित्रांनो, इनसेम तोंडावर आली. खरंच अभ्यास झालाय का? आपण कॅपेबल आहोत का आता स्कोर करण्यासाठी? स्वतःला विचारावर. नसेल ना, काळजी नका करू. पर्पल ॲट ॲप्लिकेशन प्ले स्टोरवर लगेच डाउनलोड करा. मित्रांनो, पर्पल ॲट ॲपमध्ये M1, M3 आणि मेकॅनिक्सचे व्हिडिओ लेक्चर प्लस पेपर सोल्युशन आहे. एकदम ऑफोर्डेबल प्राइसमध्ये, वेगळी प्राइस नाही, एकाच प्राइसमध्ये तुम्हाला कोर्स प्लस पेपर सोल्युशन. सो अभ्यास करा, लगेच पेपर सोल्युशन करा, तुमचे विषय स्कोर करा. मित्रांनो, ॲप्लिकेशनच पर्पल हॅटच का? कारण 100% आम्ही गॅरंटी देतो. व्हिडिओ लेक्चर जे फ्री आहे ते बघा, तुम्हाला इतके सोपे वाटतील, तुम्ही स्कोर करशाल. सेकंडरी तुम्हाला वाटलं तुम्हाला बेसिक येत नाही तरी तुम्ही स्कोर करशाल, आणि पूर्ण कोर्स मराठीत आहे. सो सध्या आपल्याकडे ऑफर आहे, हे कुपन कोड वापरा आणि तुमचा पूर्ण इनसेम स्कोर करा. सो लगेच ॲप्लिकेशन डाउनलोड करा आणि इनसेम स्कोर करा.
Only can pass those who are passing through the open region of the slit. From opaque they will get it reflected back. And here again that Huygens principle of secondary wavefront comes in a practice, that is each and every point on the surface of developed secondary wavefront will start acting as a secondary source and will produce n number of secondary waves. They travel in the same direction, that is towards the direction of screen, and will produce the ray will produce the interference pattern. The interference pattern in this grating is nothing but here is the centralmost maxima. Here is the maximum due to ray coming from one slit, maximum due to ray coming from second slit, maximum due to ray coming from third slit. This side also the same, maximum due to first slit, then next slit, then next slit, like this. And we'll see So this is what the type of intensity distribution pattern produced by the ray when they are coming from the grating surface. Addition of opaque and open width. A is the open width, B is nothing but the opaque width, that is constant, and that constant is known as a grating constant. So E is nothing but grating constant. This is what? Grating constant. Grating constant, or it may also known as a grating element. Why it is constant? Because open width is constant throughout, opaque width is also constant throughout. That is why addition of open and opaque width is nothing but constant, and that is what known as a grating constant or grating element. So here is nothing but the maximum intensity P. Here is the P1 central maxima due to ray coming from first slit, second slit, third slit, like this. N number of secondary maxima, N number of secondary minimas, and as we go away from secondary maxima, so the amplitude goes on decreasing. That is what understood. So this is nothing but, here also we try to find out what is the condition for obtaining the position of secondary maxima or condition for the maximum orders. What is the condition for to obtain the position of secondary maximum order, and obviously secondary minimas. So this is what about the grating. Second thing, after this, the another important chapter is nothing but the polarization. In between, Raleigh's resolution of resolving power is also there, resolution of light is also there, but as far as examination concerned, here you need not to concentrate on this side much more. That is what? Resolving power of a telescope and resolving power of a grating. Only try to understand what is the state and explain Raleigh's criteria of resolution. Raleigh's criteria of resolution means, when suppose this is what the single slit, and here two sources are placed. One is S1, second is S2. Light from S1 produce their effect, light rays from S2 also produce their effect. So obviously on screen we'll observe two central maximas. One, suppose P1 due to one source, P2 due to another source. Here, this is what already we have seen like this. Okay. When these two sources, the distance between these two sources is very small, may be separated by a linear distance, may be separated by an angular distance. In that case, the two central maxima may overlap on each other. So this is what, when distance is very small, the central maxima may overlap on each other. So this is nothing but P1, P2. Distance between two central maxima is very small. Central maxima of two pattern may almost overlapping, and that may, instead of giving two different image, may give a single image. This is what not properly resolved. So there is no proper resolution. It means there is no proper distinction between P1 and P2. There may be there is no proper differentiation between two central maxima, and they are not resolved. In second case, when the distance between two sources is very large, these two sources are separated by a sufficiently large either linear distance or an angular distance. In that case, you can see two central maximas are also separated by with a sufficient large distance. So they are easily distinguished. They are easily resolved. They are easily separated. In that case, you can see they are properly differentiated or well resolved. Here, they are not resolved. And third condition is nothing but when distance between two central maxima is like this. That is, the central maxima of one pattern is falling with the central maxima of first secondary minima of another pattern. Or distance between two central maxima is exactly, delta is the distance between two central maxima. If it is exactly equal with the distance between central maxima and first secondary minima of same pattern, when two deltas are equal, in that case, these two central maximas are about to resolve. They are just resolved, or they are even considered as a critically resolved. And this is what, to understand the just resolution condition, to find out limit of a resolution condition, or to calculate the resolving power of any optical instrument, maybe it is prism, maybe it is telescope, maybe it is microscope, maybe it is grating, any optical instrument which has the capability to resolve the object, which has the capability to resolve the pattern. That capability, that power is known as the resolving power of a particular instrument, or the particular prism or grating like this. You might have done one experiment in 11th standard, that is finding out an angle, calculating an angle of minimum deviation with the help of prism. You will see prism, when it is exposed to the set of light ray, the white light, it is a mixture of all 7 colors. When it strike on one of the reflecting surface, other side, it convert in a brilliant spectra. So that is resolution of white light into 7 colors. That is nothing but the resolving power of a prism. To calculate the resolving power of a prism, the condition out of these 3, no resolution, it is not to be considered. 100% 100% resolution, it is not to be considered. Limit of resolution means the critical resolution or just resolution has to be considered. And the Rayleigh scientist has given direction, that is, to obtain the critical resolution condition, what is the situation has to get satisfied, and when two patterns are critically resolved. So this is what the statement of Rayleigh's criteria, that when central maxima of one pattern coinciding with the first secondary minima of another pattern, vice versa, central maxima of P1 coinciding with the first secondary minima of P2, or P1 is coinciding with the first secondary minima of P2. This is what the P2 produced by the ray coming from second source, or P2 is coinciding with the first secondary minima of P1. In that case, they are critically resolved, just resolution, and that is what the condition is known as a limit of resolution. And resolving power is nothing but resolving power of any optical instrument is nothing but reciprocal of LOR. Reciprocal of LOR, it means limit of resolution. So this is what about question may be expected. State and explain Rayleigh's criteria. In that case, you will have to explain by considering three diagram, and then explain, write the statement, that is according to Rayleigh's criteria, the two patterns are just resolved when and only when central maxima of one pattern is meeting with the first secondary minima of another pattern, vice versa. Or the distance between two central maxima, it is exactly equal to the distance between central maxima and first secondary minima of same pattern. So this is what the statement and explanation by considering A, B, C and explain like this. So this is what about the second chapter, that is what diffraction of light. In third, that is polarization of light. It's very simple, that is
मित्रांनो, इनसेम तोंडावर आली. खरंच अभ्यास झालाय का? आपण कॅपेबल आहोत का आता स्कोर करण्यासाठी? स्वतःला विचारावर. नसेल ना, काळजी नका करू. पर्पल ॲट ॲप्लिकेशन प्ले स्टोरवर लगेच डाउनलोड करा. मित्रांनो, पर्पल ॲट ॲपमध्ये M1, M3 आणि मेकॅनिक्सचे व्हिडिओ लेक्चर प्लस पेपर सोल्युशन आहे. एकदम ऑफोर्डेबल प्राइसमध्ये, वेगळी प्राइस नाही, एकाच प्राइसमध्ये तुम्हाला कोर्स प्लस पेपर सोल्युशन. सो अभ्यास करा, लगेच पेपर सोल्युशन करा, तुमचे विषय स्कोर करा. मित्रांनो, ॲप्लिकेशनच पर्पल हॅटच का? कारण 100% आम्ही गॅरंटी देतो. व्हिडिओ लेक्चर जे फ्री आहे ते बघा, तुम्हाला इतके सोपे वाटतील, तुम्ही स्कोर करशाल. सेकंडरी तुम्हाला वाटलं तुम्हाला बेसिक येत नाही तरी तुम्ही स्कोर करशाल आणि पूर्ण कोर्स मराठीत आहे. सो सध्या आपल्याकडे ऑफर आहे, हे कूपन कोड वापरा आणि तुमचा पूर्ण इनसेम स्कोर करा. सो लगेच ॲप्लिकेशन डाउनलोड करा आणि इनसेम स्कोर करा.
now the third chapter is nothing but polarization of light. Polarization of light. In first two phenomena, that is interference and diffraction, we have seen that is light has a wave nature. But what type of vibration light ray produce while they are getting propagated? So their nature of vibration may be transverse, either they are transverse vibration or longitudinal vibration. That is proved by the third chapter, that is third phenomena, polarization of light. That is, light has transverse vibration while propagating in particular direction. Transverse vibration means the vibrations which are perpendicular to the direction of propagation, and longitudinal vibration, the example is nothing but the sound waves which are parallel to the vibrations which are parallel to the direction of propagation. So in this polarization of phenomena, it is confirmed that light has transverse vibration. In this chapter, the main is nothing but Brewster's law, Malus law, double refraction phenomena, then Huygens theory of double refraction phenomena, etc. These are going to be highlighted in a main manner. So in first thing, that is light has nature, maybe it is unpolarized light, whether it is plane polarized light or it is partially polarized light. Partially polarized light. Unpolarized light means it has vibration in all possible direction. The vibrations may be perpendicular to the direction of propagation of light. Vibrations may be parallel to the direction of propagation of light. Vibrations may be inclined to the direction of propagation of light. So when light has vibration in all possible direction, that is known as a unpolarized light or ordinary light. The good example is nothing but sunlight is basically unpolarized light, and the vibrations, they doesn't have any particular or fixed phase relationship between any two components. Second type of light is nothing but plane polarized light. Plane polarized light is nothing but the light which has vibration the perpendicular to the direction of propagation only. And the third one is nothing but partially polarized light. Partially polarized light is nothing but the vibrations which are the mixed vibration, having the component, one component may have vibration perpendicular to the direction of propagation, or the another component may have vibration parallel to the direction of propagation. And this is what the mixture of unpolarized light and plane polarized light, that is what known as a partially polarized light. Now here, suppose we consider a crystal. Any crystal which exhibit the property of polarization. The good examples are quartz crystal. Number of practical applications you can see by using quartz crystal. Calcite crystal, number of practical applications are there. Sugar crystal, topaz crystal, mica, borax, aragonite, selenite, number of crystals they are exhibiting the polarization property. For example, if we consider a tourmaline crystal, this is what the hexagonal form of tourmaline crystal, the axis of this, and if we see the light passes through the tourmaline crystal, initially it is unpolarized light. Already I told you, having vibration in all possible direction. The position of tourmaline crystal is fixed. When the light rays are allowed to pass through the crystal, only out of these all components, only those components are permitted to pass through the crystal who are parallel to the axis of crystal. It means they are converted into plane polarized light. So unpolarized light, this is what unpolarized light is converted into plane polarized light. The question you may answer like this: how plane polarized light rays are produced? If like this question is asked. So the simple answer for this is nothing but light passed through the stationary crystal. Try to understand what I am telling you. Stationary crystal, fixed crystal, it is not rotating. When it is in stationary position, when light passes through the stationary crystal, 100% it will convert into component, that is what? Plane polarized light. And these plane polarized lights, their vibrations are perpendicular to the direction of propagation. Second thing, now suppose if we consider the crystal is not stationary. The crystal is not stationary, but it is rotating. It is rotating along the direction of propagation. Crystal is under rotation. Example I have taken tourmaline. You can consider any crystal. All crystal exhibit the same property. So when it is rotated, in that case, first position, suppose it is like this, stationary, which component will come? Who are parallel to the axis of crystal. Second position, slightly inclined. These components may get it restricted, but there are unpolarized light containing the component which are inclined, so they can come. Perpendicular position, so axis of the crystal is perpendicular to the direction of propagation. All component may get it restricted, but some horizontal components are present as it is unpolarized light. They are parallel to the axis of crystal that time, they can pass. Continue the rotation, inclined component may come. So what we understood here, that during one single rotation, try to understand, it is applicable to all type of crystal, though I have taken example of tourmaline, calcite, quartz, every crystal will show this kind of property. So when crystal is rotated, during the single rotation, unpolarized light will come as a unpolarized light. Means what you see, unpolarized light is coming as an unpolarized light, means definitely there is no change in the intensity. Intensity is not changing, no change in the intensity. But suppose the previous example what I had taken here, that is when crystal is not rotated, it is stationary. That time, here, that unpolarized light is not as an incident, it is plane polarized light, suppose. Try to understand, incident light is plane polarized light. Crystal is under rotation. In that case, what do you see? What do you see here? For first position, when crystal, the component incoming vibration parallel to the crystal will come with the maximum intensity. Second position, it is slightly rotated, under rotation, tilted position. So obviously intensity has to get it affected. So intensity is reduced. Further increase in the rotation, intensity is reduced. Intensity is reduced. Intensity is reduced. One position, when the axis of crystal is perpendicular to incoming vibration, there is no intensity, zero intensity. Continue the rotation, intensity start improving. What did it explain? What you understood? That when incident light is on plane polarized light, it is allowed to pass through the rotated crystal. Try to understand. It is allowed to pass through rotated crystal. So during rotation, intensity is not remaining constant, but it is goes on changing. It changes from initially it is maximum and finally it becomes minimum, which is 100% equal to 0. So try to identify the nature of light, whether it is plane polarized light or unpolarized light or partially polarized light. We can understand through this particular experiment. Allow the light ray to pass through the rotated crystal. If it is unpolarized light, intensity does not change. If it is plane polarized light, in variation intensity is observed, maximum to minimum. One position, minimum intensity 100% equal to 0. And in third situation, if it is partially polarized light, if it is PPL means partially polarized light. When it is partially polarized light, in that case, intensity will change. There is variation in intensity, obviously from maximum to minimum. How it is? Because presence of plane polarized light component, which shows the variation in intensity. But at one position, that is when axis of this crystal is perpendicular to the direction of propagation of light, in that case intensity minimum but never comes equal to 0. Why it is not coming equal to 0? Because presence of horizontal components are there who are parallel that time to the axis of crystal and will show minimum intensity but definitely not equal to 0. Means to identify the nature of light, when it is partially polarized light, that is when intensity is varying, changing from maximum to minimum but never coming equal to 0, in that case the nature of light is 100%. It is partially polarized light. It means it is a mixture of unpolarized light component and partial plane polarized light component. When there is no change in the intensity, it is unpolarized light. When intensity changes from maximum to minimum, minimum 100% becoming equal to 0, plane polarized light. Variation in intensity from maximum to minimum, intensity not coming equal to 0 but it is minimum, then input light is 100%. Partially polarized light, it is a mixture of plane polarized light and unpolarized light. So this is basic concept of the phenomena that is polarization of light. Now here, as far as examination point of view concerned, we try to understand one phenomena explained by Malus, and that is what known as a Malus law. Malus law. Here, consider instead of single crystal, we consider pair of crystal. Let us say first crystal P, second crystal A. Input is unpolarized light having vibration in all possible direction, allowed to pass through the first crystal. First crystal is stationary. Try to understand. Position of first crystal is fixed. Second crystal is not fixed, but it is under rotation. So as first crystal is fixed, tell me what is the nature of output produced by first crystal? It is definitely converted from unpolarized light to plane polarized light. Unpolarized light to plane polarized light. Okay, because only those components are allowed to pass who are parallel to the axis of crystal. So as this crystal is converting light from unpolarized light to plane polarized light, in other way, the first crystal, which is stationary, producing a polarized light, so first crystal may be known as a polarizer. So this is what known as a polarizer. Now the input to the second crystal is not unpolarized light. Which one it is? It is a plane polarized light. It is allowed to pass through the second crystal, which is not fixed, which is rotated gradually along the direction of incident axis. So during rotation, what we see? First position, maximum intensity. Rotation increase, intensity goes on affecting, decreasing, 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 perpendicular position 0, then increasing, 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 increasing like this. Because the nature of light is plane polarized light. So when plane polarized light is passed through the second crystal, which shows the change in intensity, variation in intensity, it analyzes the nature of light, it analyzes the variation in intensity. The second crystal is also known as a analyzer. So this is analyzer. A stands for analyzer, P stands for polarizer, and it shows variation, change in intensity. Change in intensity. So this is what intensity changes. Change in intensity. Okay. So intensity changes. Now what Malus has studied, it is clear that intensity variation is there. Intensity is changing. But Malus has given focus on the very important point that how intensity is changing. Don't answer simply. It is maximum to minimum. Minimum equal to 0. Not like this. How the intensity of light, try to concentrate on my statement. How the intensity of light after the analyzer. What I told you, not after the polarizer. After the polarizer, it is plane polarized light. Agreed. But after the analyzer, there is change in the intensity as it is observed. How the intensity of light after the analyzer changes. How it varies. How intensity varies. How intensity varies from maximum to minimum. So that focus is given by Malus, and that is what known as a well-known Malus law. Let us try to understand Malus law like this. Here we consider amplitude of light produced by polarizer. Focus on my statement, concentrate on my statement. Amplitude, maximum amplitude of light produced by polarizer means which one? This one or this one? Obviously this one. Let us say it is AM. Then that AM is resolved in two components. AM, the maximum amplitude light of polarized light. Polarized light means 100%. This light is resolved, separated. Resolved means separated, divided, distributed or differentiated. Separated into two components. one component has amplitude A cos of theta, second component has amplitude A sin of theta. Amplitude of resolved component A cos of theta, A sin of theta. Sin theta and cos theta, they are standard resolution factors. How? Because we know sin square theta plus cos square theta is nothing but 1. Okay, so AM is divided. Here we can say AM sin theta or AM cos theta. AM cos theta is an amplitude. Try to understand. AM cos theta is an amplitude of resolved component which is parallel to the axis of crystal. Try to understand. AM cos theta is an amplitude of crystal. This is the 100% question you can expect in this exam. So AM cos theta is an amplitude of resolved component parallel to the axis of crystal. AM sin theta is an amplitude of resolved component which are having vibration perpendicular to the axis of crystal. So obviously we know out of these two components, which components are allowed to pass? Out of these two components, one is having amplitude AM sin theta perpendicular to the axis of crystal, AM cos theta parallel to the axis of crystal. So out of these two components, which components are allowed to pass through the second crystal? Definitely the amplitude of resolved component which is AM cos theta and which are parallel to the direction of crystal, they are allowed to pass. Where the amplitude of resolved component who are perpendicular to the axis of crystal, they does not allowed to pass. So only those components will come after the analyzer, and intensity vary as per the variation of the amplitude of this resolved component. We know intensity is directly proportional to the square of amplitude. So here we can write I is the intensity of light. I is the intensity of light finally produced after analyzer. Im is the intensity of light after the polarizer, and it is nothing but cos square theta. So this is what known as a Malus statement. I equal to Im cos square theta, where I is the final intensity of light, Im is the intensity of light produced by polarizer, and theta is nothing but angle between plane of polarizer and plane of analyzer, and hence the Malus law or Malus statement. This is what the mathematical form of Malus law, and theoretically the Malus statement can be described like this, that intensity of light after analyzer is directly proportional to the square of cosine of angle between plane of polarizer and analyzer. Angle between plane polarizer and analyzer. Let us say, suppose two planes are parallel. If two planes are parallel, when P is parallel to A, P is parallel to A means what? The plane of polarizer and plane of analyzer, they are parallel. When they are parallel, it means angle between these two is nothing but 0. So Malus statement mathematical form, I is equal to Im cos square theta. So where theta is 0, cos square theta 0, cos 0 is nothing but 1. So I is nothing but Im. This is what the maximum intensity when two planes are parallel. So maximum intensity produced by polarized light will get it transmitted after the analyzer. So this is what maximum intensity. Then next extreme condition is when two planes are perpendicular. Two planes are perpendicular. It means plane of polarizer and plane of analyzer, they are perpendicular, it means having angle that is 90 degree. In that case, theta is nothing but 90, and if you see, when theta is 90, so cos theta is 90, cos 90 is obviously 0, cos 90 0 means I is nothing but 0. I 0 means here what we have shown that two planes are perpendicular with respect to each other. In that case, intensity of light is nothing but minimum, and minimum is 100% equal to 0. So this is nothing but about Malus law. Question may comes like this: state and explain Malus law. Statement. What you can write? Intensity of light after analyzer, it is directly varying, changing, or proportional to the square of cosine of an angle between, theta means angle between plane of polarizer and analyzer. An explanation, you can explain as just now I given the direction that resolve the amplitude of polarized light into component and explain accordingly. So this is what nothing but Malus law. Now second, after this, if we consider the crystal, any crystal, that is what calcite crystal, quartz crystal, mica crystal, borax crystal, normally practical applications, for practical application calcite and quartz crystals are considered. But in medical field, to analyze or to find out the percentage of sugar in diabetic patient, sugar crystals are mainly used, which will help us to know about that level of sugar in the blood or urine of that particular diabetic patient. So number of practical applications are there. Even quartz crystals are mainly used to design the spectacles, so they are mainly used, or even the glass windows, the windows of aircraft, windows of high story buildings, they may be even designed with the crystal. So because they are possessing the polarization property, so to reduce the intensity, so particular crystals are mainly used. Now out of this calcite, quartz, tourmaline, mica, borax, tourmaline crystals, they are available in a big sizes. So normally while designing windows, glasses of main buildings, tourmaline crystals are used. Windows of aircraft, tourmaline crystals are used. And calcite, quartz, they are available in a small size. So to design the glasses of spectacles, the quartz crystal, calcite crystals are used. So these are the practical application. The main property what crystal possess, the crystal media is anisotropic media. Try to understand. The word is nothing but anisotropic media. Glass medium is isotropic medium. Isotropic medium means when light travels through the glass medium, there is no change in the velocity. But when light passing through the crystal, any crystal, basic property of crystal is nothing but it convert into two types of light ray. One is ordinary rays, second is an extraordinary ray. Ordinary ray travels in the same with the same velocity in all the direction inside the crystal, while extraordinary ray travels with the changing velocity while traveling inside the crystal. So they are called as the extraordinary ray and ordinary. Why? Because velocity of E rays goes on changing. Basic formula we know, that is mu, the refractive index, may be also defined like this: Va, the velocity in air, and Vm, the velocity in medium. Velocity in air, it is constant. Velocity in medium is changing. As velocity of ordinary ray remains constant, and velocity of extraordinary goes on changing. So that is why it is known as a E rays and O rays. So when crystal ray, incident ray passes through the crystal, it divide into E rays and O rays. So this is what unpolarized light passes through the crystal is divided into E rays. Their vibrations are lying in the plane of crystal and their vibrations are perpendicular to the plane of crystal. So this is what O ray, this is what E ray. So the phenomena of light, that is incident light, is divided into two refracted ray. This is what known as a double refraction phenomena. So any crystal possesses the property of a double refraction. Ordinary ray having vibration perpendicular to the plane of crystal, ordinary extraordinary ray having vibration parallel to the plane of crystal. So when you focus on a photographic plate, you will observe two images. One is due to extraordinary ray and second is due to ordinary ray, and when it is rotated, the image due to E ray rotated because its vibrations are lying in the plane of crystal, and image due to O ray, they remain stationary as it is perpendicular to the plane of crystal. Ordinary ray travels with the same velocity in all direction, where velocity of goes on changing with respect to direction inside the crystal. That is what E ray. After that, they travel with the same velocity. This understanding we can understand with the help of Huygens concept. So this is what whole thing about polarization. Now the second unit, is nothing but laser and fiber optics. Fiber optics. Ordinary light rays is converted into laser rays. Laser, that is light amplification. Light amplification by stimulated emission of radiation. Light amplification. So two words are very important: light and stimulated. Light means it works on the optical range, that is visible light radiations having wavelength 4,000 angstrom in it to 7,000 angstrom in it, that is visible region, and stimulation, which shows that the light is converted in a single direction in a single plane, single phase. Okay, so light amplification by stimulated emission of radiation. The main characteristics are, they are highly coherent. Laser light rays are highly coherent. They are highly coherent. Second, they are highly intense. Third, they are highly monochromatic. And then they are highly unidirectional. Laser rays are highly unidirectional. So highly coherent, that perfectly in a single phase, in a constant phase, so continuous constructive interference is going on. constructive interference, so the intensity goes on increasing. They are highly intense, highly monochromatic because single wavelength, and they are traveling in a single direction, miles a distance, so they are highly unidirectional. These main four characteristics leads the use of laser almost in each and every field as far as practical application concerned. In the field of industries, in the field of medicine, in the field of scientific laboratory, or in the field of defense, almost in every field lasers are used. Lasers are used to operate the detached retina of sensitive part of our body, that is what eyeball, as the lasers can produce the temperature only at the particular position where they are focused. So lasers are used. Even lasers, may consider as a destroyed ray. So high power lasers, when they focus on any particular objects in miles, in a fraction of second, that object may get it destroyed. They are highly unidirectional. So lasers are mainly used to transmit the optical signal as a carrier wave. So they just guide the path, or they take the optical signal in the field of communication. So number of applications are there. Main, that is what the solid state laser, semiconductor diode laser, and carbon dioxide gas laser. Semiconductor diode laser works on the simple principle, that is what? The population inversion, the PN junction, or you can say that particular metastable state, and all these properties. So population inversion is there. Here, how the stimulation is observed, that we can understand. So this is what transition in two energy level. E1, E2, E1, E2, E2, atoms at ground level, and photon is applied with the energy E2 minus E1 is equal to h nu. What happened? Due to this application, the atom absorb the energy and will follow the transition from lower state to the higher state. Higher state is nothing but excited state, unstable state, which has limited lifetime, varies from 10 raised to minus 3 second to 10 raised to minus 9 second. If lifetime is minimum, so obviously that transition will take place from higher level to the lower level without any triggering action. And as per the quantum theory, whenever transition is observed from higher level to lower level, energy is emitted. This emitted photon has not having a control in the direction. They are non-directional, they are not in phase, or even they are not in particular continuous direction. So they are known as a non-radiative transition. So these transitions are observed by their own, that is by having that much energy to coming down, or as far as lifetime is finished, they come down. So this is what known as a spontaneous emission. In second category, when atoms are at the excited level and before coming down, when they are triggered from higher level to lower level, so due to action of incident photon, when the transition is observed, so these two photons are developed. So they are perfectly in one phase, they are perfectly in single direction, and these are nothing but, you can say, they are stimulated. So this is what stimulation, stimulated emission of a transition. Stimulated emission, this is what non-stimulated means, spontaneous emission of a transition. They are perfectly in same direction, they are constant in phase, so they are perfectly coherent, and that is what you say, they are highly intense. They go on adding, and you can see that they are highly intense transition. So these are nothing but lasers. So semiconductor diode laser, the homogeneous laser and heterogeneous laser. In carbon dioxide laser, you can understand same, that how to improve the population inversion, how to improve the resonance condition, or how to improve the particular intensity of light, that you can understand in the particular lasing action.